Hello, and welcome to the Smart City Planning with ArcGIS Urban and CityEngine Technical Workshop at Esri's Developer Summit 2020. My name's Eric Whitner. I'm the product manager for ArcGIS Urban and CityEngine, and what I want to do is introduce you to ArcGIS Urban, explain what it does, give you a little bit of demonstration of what it does, talk about what's came out at the last release, 1.1, and then go into a little bit of the roadmap of ArcGIS Urban and what we can expect to see in the next couple of releases. And then I want to talk about CityEngine and how CityEngine and ArcGIS Urban work together as technologies and some of the enhancements we've made to CityEngine which might interest programmers and developers. With me is my colleague from the Zurich R&D office, and I'll let him introduce himself.
Hello, my name is Michael Vandenberg. I'm the software development lead on Urban, and I will talk to you about the software architecture and the API of Urban.
Thank you, Michael. So, most of you probably haven't heard about ArcGIS Urban. It's a pretty new product from Esri. It's a web-based urban planning tool that is focused on enabling planners with GIS technology without having to have them understand the depths of, traditional GIS tools like Desktop or ArcGIS Pro. It is built on top of the ArcGIS platform, of course, so it uses the services that we're all familiar with, be they feature services or scene services, to present its data. And it utilizes the procedural runtime from CityEngine to create representations of what planners work with on a day-to-day basis, plans, into compelling 3D representations and into information that they can use to guide decision making. So it's really composed of a couple core components and capabilities. The first one is providing this digital twin as a context for change. So it's a place where you can collect your 3D base map, your buildings, your trees, all your zoning polygons, your parcels, your overlays, all together in one place, and becomes a system of record for zoning and a system of context for your 3D information. That's all delivered in an interactive viewer that you can navigate around and look at different parts of your city. With it come a set of indicators and metrics. These indicators show trends that are happening in your city, so you can actually determine where you need to make change. And some of those indicators are coming from Esri, so we're publishing them and making them available out of products like the Community Analyst and Business Analyst. But you can also publish your own indicators. So many cities do their own analytics, or many companies do their own analytics, and they want to provide those as context for deciding on how to make change. As well, we measure the change that plans and projects do as metrics, and we make those metrics available in summary as indicators in ArcGIS Urban. So you can see the cumulative impact of many plans and projects onto your thematics maps as indicators. And then you can use Smart Search to find plans, projects, and indicators across the larger interactive viewer. One of the core capabilities of ArcGIS Urban is the ability to visualize projects citywide. So many cities are undergoing a very large amount of change. They have many different projects that are being proposed across the city. For some of those, they have simple locations. For some of those, they have more complex 3D models. They want to combine all that information in one place where they can see what the status of all those projects are simultaneously. And then when they're interested in a specific project, click on it and get information about it. And this allows them to plan in context so they can see the change that's already been approved and understand how that might impact the plans that they're doing on a day-to-day basis. And again, you can have these capacity metrics associated with these projects, and those can be summarized up into these indicators to give you a sense of the larger impact of all these projects on your urban area. And then it also allows for streamlined reporting on projects, and that it links to Hub so that you can create project pages and then hang additional documents related to the project off those project pages, or link out to external reports on projects as a way of providing a geographically driven access to reporting on projects. It also improves the planning productivity by giving a more compelling representation of what a zoning change will actually do. So all cities have these regulatory codes, these zoning, land use or zoning codes that are guiding the direction of the city. What we do is we take those codes and distill them down into a set of attributes that we can use to procedurally generate through the procedural runtime a visual representation. And we actually generate a couple of visual representations. Here on the right, we have plausible buildings, which are based on the regulatory constraints on the parcel. And we can also actually create visual representations of the zoning envelopes that constrain those buildings. This allows planners to immediately see the impact of zoning change. They can rezone an area, like for a specific area plan. So this is the dot avenue plan, for instance, we're looking on the right, and then choose which parcels they think are most likely to redevelop, or do a suitability analysis and select which parcels they think are most likely to redevelop those based on their zoning change, and see what those buildings might look like. The more important thing about the procedural generation, though, is that these buildings have usage types inside of them which drive reporting. So they tell us how many people are in there, how many households are in there, how many jobs are in there. And that downstream reporting actually allows them to understand whether this proposed scenario in a plan is a good thing or a bad thing. And it can compare multiple scenarios and decide which one is best. It also, as a platform, facilitates better engagement with the public, because the public gets to see or review proposals, proposed plans, and proposed projects that the city decides to share. And they can use this as a platform for collecting comments and feedbacks by publishing a scenario or a plan or a project out, and then wrapping it in other applications, for instance, Survey 123. This allows them to collaborate with the public on getting feedback, and also allows them to give feedback to the AC, the architecture, engineering, and construction companies that are submitting projects to them. And then there's also kind of a generic way for citizens to go in and share their ideas for improving the city overall. ArcGIS Urban is a single application, but it's really split into two views. There's a public view and there's an internal view. And the public view is composed of all the plans and projects and indicators the city has chosen to share with the public, that city leaders, real estate developers, citizens, non-government organizations can see the activities that are going on in the city so that they're aware of the change that's coming. The internal view is where planning professionals work to actually author plans and projects. So they can create a new plan, create a scenario, propose change, and measure the impact of that change and make decisions about what kind of change they want to pursue. And it's also a place where the GIS professionals who are supporting them can share additional information, like additional indicators and additional analysis, to support those planning professionals if necessary. So rather than talk about it for a whole lot longer, how about we take a look at ArcGIS Urban in action, and we look at a little demo. And for this, I'm going to use the city of Pasadena. The city of Pasadena has an area on the south called South Fair Oaks. They've been using ArcGIS Urban to envision what that area would look like if they redid the zoning. So here is the South Fair Oaks area in southern Pasadena. What they've done is they've gone in and changed the zoning designations for the area along this street to increase density and create a mixed-use development for this area. The zones are applied to the parcels that overlap them, and these parcels have assigned building types that are validated against the zones. So right now, this is actually a 6-story mixed-use office retail building, but I may decide that I want a mid-rise residential. I want to add more households into this development. I just select that building type, and the building automatically procedurally generates and changes. Now, I can have these building types automatically allocated based on zone, but even if I don't like the building type, if I don't like the defaults that I'm getting, I can actually go in and customize. So I can inspect the individual parcel. I can override the total number of floors. I can override the setback. But more exciting, because this is a procedurally generated building, it understands what's inside of it, what those space uses that it's defined on a per floor basis mean. And it generates for us these measures of the total population that are going to be added, the number of households, the number of jobs. And that allows me to compare scenarios and decide which scenario is best. I can see all the different building uses that are being prescribed in this scenario and how many square feet they are and how many persons they're applying. I can see all the different zoning types across my entire plan and what the total area of those zoning types are and the kind of restrictions they put on housing to get a sense of what this whole plan was. Let's take a look at a project. So also in South Fair Oaks, we have 690 Fair Oaks, which is a conceptual building or proposed building. It's in the early stages of being proposed. And so here what we've done is we've taken a 3D model representation, inserted it in there, and used some of the rendering techniques and the JavaScript API to give it this sketchy edge, to give the citizens a sense of what would be there without, making it look so permanent that they don't misunderstand and think that all the decisions have already been made for them, right? As projects progress, right, they can get more detailed and more specific. So here we have 650 South Raymond, right? This is actually a BIM building from Revit that was imported and published as a building scene layer through ArcGIS Pro, and then that building scene layer was brought in to represent this project in this section of Pasadena in high detail once there was an architectural proposal ready. So you can see it gives the citizen a sense of what's going on, right, across their city. And if we zoom out here, we can see here's all the projects that are going on in the city of Pasadena right now. So if you're a citizen, you can see all the things that have been approved in green, the things that are currently under review in yellow, the things that are under construction in red, and understand where the change is coming. And then these polygons represent where larger efforts are being made to replan and rezone the city to represent the change across the city of Pasadena. This is just a brief introduction to ArcGIS Urban. I want to talk a little bit about where it fits into this kind of larger platform story. So, as a platform for planning, the first step is to create this digital twin, create this system of record. And that comes from the GIS information that cities already have. Publishing the 3D buildings as a scene service, publishing the zoning, publishing the parcels, publishing the overlays, publishing any indicators that the planners have requested from the GIS professionals to help them make their decisions. It's sort of classic GIS work and creating services. But once it's all up in ArcGIS Urban, then the planners, the planning professionals, don't have to go back to the professional GIS products to create and collaborate on their plans, projects, and indicators. They can do that on their own directly in ArcGIS Urban with these focused urban planning workflows, which are much easier for them to use and to understand. Once they've got a plan or a project to the point where they're interested in getting feedback, they can share it, right, out to the community and engage the community to get feedback. And in this case, they can share it and wrap it in hub initiatives to engage with either real estate developers who are trying to solicit to do proposals, or citizens where there might be a development in their neighborhood and they need feedback and they have a statutory requirement to get comments, or even share it as a fancy story map, right, for the city council, so the city council better and the leadership of the city better understand what's being proposed. And then if that's not enough, you can always extend, right? So you could wrap what you've built in ArcGIS Urban and Survey 123 or Experience Builder, right, to create custom applications or to create custom engagement environments where you can ask citizens specific questions. Or you could take a planner project, push it out to CityEngine, do architectural visualization, push it out to a VR experience that you want to share on a Samsung Gear VR or an Oculus Go or an HTC Vive to give people kind of a more immersive experience. Or maybe you want to make more detailed maps, so you take it to the Adobe Creative Cloud, or you want to add more details to your plans, so you pull it into Community Analyst and enrich it with Community Analyst information. So let's talk about what are the highlights of 1.1. 1.1 came out just at the end of last year, and there's really five main highlights I wanna touch on here. The first one is example cities. So we've partnered with a few cities and they've shared their data with us and allowed us to use it in ArcGIS Urban. And you can go to urban.arcgis.com if you have a license. You'll see these example cities. And we've already set them up with plans and projects and indicators. And you can just click on this blue button, right, where it says Set up Urban. And we'll go ahead and launch a fully fleshed out version of Urban that you can explore and learn how to use ArcGIS Urban without having to go through the process of setting up all your data first time before you ever get a chance to use it. And so in this example, for instance, we're doing Melbourne. The other thing you can do is you can share a scenario from a plan. So here we have Fisherman's Bend again in Melbourne. I can choose to share that plan. I can pick out the layers within the scenario that I want to share, and I can share it as a map or as a web scene. Now, why would I want to do that, right? Well, okay, so here I've shared it as a web map. Well, for instance, I could actually take it into ArcGIS Maps for Adobe Creative Cloud, right? Pull this into Illustrator and create a more compelling map of it in Illustrator. I could take that web scene, right, and then from Hub, link in a link to that 3D web scene, wrap it in a story map, and create a story explaining to the citizens why this proposal is a good idea. I could take this plan, freeze those procedural models as 3D models, pull them to ArcGIS Pro, and do additional analysis using a local government template. I could take the reports that are being generated, the capacity metrics, export them to Excel, open them in table, and do further analysis. Or, at the very simplest level, I could just take a screenshot of my proposed project and insert it in a report that I'm developing for my leadership. So just another example. Another kind of subtle change is I mentioned that inside these buildings we have these different space uses. These space uses drive the metrics and the total number of households and jobs that they generate. New at 1.1, you can actually customize that space usage table directly from inside ArcGIS Urban. So if you're dealing with a new proposal, you could create a custom building use type for a specific proposal, or if you need to make changes or edits to your use types, you can make custom ones on the fly. Another interesting addition for 1.1 was this integration with a mapillary for Street View. So we're here in Boston, again at the Dot Avenue project, and I drop myself on the ground and I can see my proposed buildings in the context of real world imagery collected by mapillary to get a sense of the context of what kind of changes are going to happen when I compare procedurally generated world to real world. And then, last but not least is this ability to import directly from a layer. So we have a layer with preset symbology. I can actually import the layer symbology into ArcGIS Urban and populate my zoning layer with that pre-existing symbology without having to recreate it, which makes getting zoning into ArcGIS Urban much, much easier. So I want to talk briefly about the roadmap for ArcGIS Urban in 2020, our vision, the key epics that we're trying to address this year. And I'll turn it over to Michael to talk a little bit more about the software architecture and the API for ArcGIS Urban. So right now we're actually bringing Hub and Urban closer together as two products. So we've had this sort of workflow where we do GIS collection, comprehensive planning, specific plans to improve specific areas, rezoning and variance, project submission, project review, and approval and tracking as kind of the chain of change that a city goes through. But Hub actually mirrors that really well, right? So they have an open data portal for sharing GIS data. They have a way to involve citizens in giving feedback on comprehensive plans. They have a set of identity that can be used to collectively collaborate around developing specific plans. They have identity that we can tie to rezoning and variance to engage with citizens who are proposing small specific change on their own parcels. When it comes to project submission, the hub can be used to provide identity to architecture, engineering, and construction companies that are submitting projects to ArcGIS from Urban externally. And then in the project review process, it allows us to understand what the stakeholders are saying by wrapping these plans and projects in these survey 123s, story maps, and all these engagement tools that Hub makes available for us, and then share that information back, not just as a 3D map in ArcGIS Urban, but as a set of pages and initiatives in Hub that allow us to engage with the public. So really for the next year of 2020, we're going to be focusing on three things. One is comprehensive planning. The second one is project submission. So that's the external submission from architecture, engineering, construction companies with 3D models, or from developers of 3D models into the city. And this collaboration and project review process that we're going through, and in all these cases, trying to build and bring Hub and Urban closer together. So first, for version 2, is we're adding a land use plan. So we've had existing zoning plans for a while that they create plausible buildings based on the zoning regulations. Land use plans are a kind of a more generic form of that, a comprehensive plan, whereas a zoning plan is more of a specific plan. So we'll have existing land use, we'll have future land use, and the ability to create different scenarios of future land use. There'll be two-way validation between zoning plans and land use plans, and you can choose which scenario of the land use you're zoning against, and they will generate the same kind of capacity metrics, but there'll be coefficient-based capacity metrics, and then tools for allocating specific building types based on land use plans. And we really expect that to be popular with people who are doing much larger area plans than specific zoning plans. We're adding in a whole new set of advanced capacity metrics. They're based on several partners have offered up their methods and their coefficients for calculating capacity metrics on development projects, specifically land use and zoning plans. And so we're working with them to integrate those expert knowledge directly into our capacity metric system. We're adding in an API for extending ArcGIS Urban. Really, right in the first year, we're targeting on the permitting integrating permitting systems into ArcGIS Urban as a source for projects and keeping projects populated and up to date. But the API is really meant for all partners to be able to publish plans, projects, and indicators to ArcGIS Urban. We're adding in a framework for collaboration and markup, so you can add comments on plans and projects. We're going to be supporting custom building massing models and project authoring directly inside ArcGIS Urban. So if some of you saw the participatory planning example from last year's Dev Summit, if you haven't, I recommend you check it out. Those kinds of sketching and creation tools directly in projects. We'll be adding in an interactive line of sight tool as our next interactive analytic tool, and then we're going to make a whole bunch of enhancements to the zoning to support things like sky planes off the edge of parcels, to support different type of building shapes, adding in L, O, and U shapes to the building forms, not just rectangular and parcel fit, and that will continue to progress as we move forward. For 2.1, we're going to be doing this project submission workflow where someone can come in, drag and drop a 3D model into a project, rotate, translate it, scale it, get it into the correct position, and then submit that to the city for feedback and review. We're attempting to support integrated mesh base maps at 2.1, so that's the ability to suppress a portion of a mesh and then replace it with a procedurally generated building. We're going to be doing some non-parcel boundary-based sky planes and some buffers. These are basically Booleans that are going to impact the procedural generation within a parcel. We'll add support for local coordinate systems. We're going to do some work on our adding in our suitability analysis tool that also does allocation of place types, which are specific mixes of building types, more advanced zoning enhancements, adding in different additional shapes, F, T, and E buildings, and then some advanced land use zoning enhancements as well with additional capacity metrics. And ArcGIS Urban 2.0 is targeted for release just before UC in June. 2.1 tentatively is targeted for October. As always, my safe harbor statement. Features shown on this roadmap may change before release. They may flip around between 2.0 and 2.1, depending on resourcing and what's more difficult. But this is what we're focusing on for the year. So with that, I'm going to turn it over to Michael to talk a little bit in detail about the ArcGIS Urban API and then the software architecture behind ArcGIS Urban. Michael, the floor is yours.
So I will try to explain a little bit the software architecture of ArcGIS Urban. Urban is built up on quite a bit of components. First of all, ArcGIS Online is the platform where we store our data, our feature services. On top of that, we've built an ArcGIS Urban API to interface with that. We also use the CityEngine procedural runtime. We use the JavaScript API, and then on top of all these technologies, we put our Urban front end. This front end, the tech stack is built up of React, Redux, Redux Saga. As I said, we also use a JavaScript API inside this React application, and we use the procedural runtime from CityEngine to generate 3D buildings using WebAssembly. This is a front-end application. This builds up on top of the Urban API, which itself uses the REST API, Apollo, and GraphQL. And so the requests between the front-end and the API are using GraphQL queries. So I will give you a demo of this REST API as well as a demo of how React works with the JavaScript API. So I'll start with the GraphQL Urban API. So first of all, the reason why we do this. We do this first of all to reduce the complexity on the front-end application so that a lot of tasks like creating a plan or a project can be done on a server and not on the front end. We also do it to simplify integration with other applications such as CityEngine, and in that sense it's also a gatekeeper of the data model, so people cannot just write anything into the data model. We chose GraphQL for a couple of reasons. One is the ability to have tailored requests, so that, for example, you could query plans, projects, and indicators all at once, or portions of those. So you don't need to create special REST routes for each of these requests. You can just assemble them as you want. Also, because we can introduce validation and type checking, again, a bit this gatekeeper thing of the data model, and then also the ability to get detailed error messages so that it's easier to understand why something doesn't validate or why something doesn't work. I will give a short demo of this using GraphQL Playground. So as you see here, this Playground example is connected to the Urban API. Here you see a very simple request, which I've called a very simple query, which I've called get urban events. What it will do is just query the urban events. These are plans or projects, and ask for a global ID and a name. If you run this here on the right, you see the results. There's two results, each with a global ID and a name. Actually, I would like to also find out a bit more about these events. So I can go here in the Docs tab, and I can see here the urban events query that I'm doing. I can see which attributes are available and which type of attributes those are. I can see that right here. For example, I would really like to know the event name, and I would also really like to have a description of them. So I can just add that to my query. Event type, I would like to know, and the description. And then if I run the query, I will see here now that the first one is a plan, and it has a description. And I will see that the second one, the skyscraper, is a project, and it also has a description attached. So here you can assemble queries as you want, and get the corresponding result really easy, really clean. In the second demo, I will try to create one of these urban events. I will try to create a plan. So I have here another, in this case, a mutation. I'm going to create an urban event with a couple of attributes. I've defined those attributes here, but to test the API, I've put a wrong event type. I've put sketch instead of project. And then if I run, I get here an error saying that event type should be one of the allowed values, plan or project. So I can go in and change it to project. And then if I run, it will run and give me a new urban event, a project that I've created. So now if I go back to my example of querying them, it should end up in the results. And yeah, there it is, the first one. This is the project I've just created. And to show that this actually works, I can also show this in Urban. So if I refresh my projects, I get here a new one, Alexandria, the one that has been created now. Yeah, there it is. Then to React SceneView, which is a component we've created to facilitate the integration of the JavaScript API into React applications. So that's in the whole technology stack here on the front end. So our goal is to be able to have a 3D map, as you've seen in Urban, as a React component. And we don't want to mess with Dojo, we don't want to mess with Esri Loader in our front end. So we created this wrapper called React SceneView, which wraps the SceneView, a web scene, and layers and so forth from the JavaScript API and lets you use them in a React application. So this is available on GitHub. You can npm install this. There's an explanation on how to use it, and it's very simple. You import the components, and then you can, for example, create a scene view and add a web scene, or you can add individual layers, or you can add layers and a custom base map. You can add all kinds of different things to your scene view dynamically using React Scene View. And now I will give a little demo of that. So I'll demonstrate this with a little React Hot Reload example. So here we have a little example application. I changed the base map to satellite. You see it updating in real time. Now we will add a layer to the scene. So I just add that component, that React component of the layer with a portal item ID. This takes a moment to load in, but this will bring in the buildings onto the map. There we go. As you see, the app doesn't have to reload because it's React. It's just hot reloading these things. So here, another layer with trees. I just add it to the scene. I'll have to wait a moment. It's quite a large layer, and then the trees will start popping into the scene. Then we can do interesting things, changing props on the components. For example, we can add an edge renderer to the buildings layer to give these white buildings a bit of an edge. And there you see the map updates. You have to zoom in a little bit to see the edges appearing on the buildings. And then I can go and make changes to that renderer. For example, I will change the fill to pink and save it, and the buildings update just like that. Back to white, and I will try now a different edge color, for example red, and then the buildings have red edges. So this makes it really easy to quickly prototype React applications with the 3D map. You can quickly try out things and see the results immediately, just like you would create any React front end. So here I add some UI components like a compass and zoom buttons, and you can just see that as you code. Now I remove the trees and they're gone. Now there's some really cool stuff inside React SceneView. For example, we have some of the measurement tools from the JS API. So I can, for example, quickly add a distance measurement tool, and just by saving it, it's there, it's active, and I can measure distances. I can also add the slice tool and just paste it in as a component, and it's added to the scene view. So I can go ahead and make slices in 3D.
Thank you very much, Michael. Very interesting. The software architecture of Urban, the API, and the React platform there that allows you to dynamically add layers to Urban. So I wanted to continue on and talk a little bit about Esri CityEngine. Most of you are probably familiar with it, but I'll just do a brief what is CityEngine, talk about how it integrates with ArcGIS Urban, how it can be used, demo how it can be used to do some site design work on urban data, and then talk a little bit about advanced workflows with that data from ArcGIS Urban. So CityEngine, of course, is a tool for writing rules for procedurally generating forms. They could be buildings, could be simple representations of masses, more compelling representations of textures, representations that are thematic that show the interior of buildings. And you can see we've used this capability to create metrics, and this is actually what's powering ArcGIS Urban on the back end and creating all those performance metrics. But CityEngine takes it a little step further. You can create things like streets and streetscapes with procedural rules. You can do block subdivision of the blocks that those streets define. So you can create more than just buildings. You can actually create whole urban environments, and I'll show a little bit of that in more detail in Pasadena. It also integrates with the platform, so you can reach out and get GIS information from ArcGIS Online or ArcGIS Enterprise. You can download base maps from ArcGIS Online, elevation information online. You can get base map information from OpenStreetMap and download those in using the getMap data function in CityEngine, and then by applying rules, rapidly create context. And this is, if you are an AEC who's trying to build context around a project, this gives you a really quick and easy way to create that context without having to go hunting for 3D building models from a vendor or from a city. So just by applying a rule, applying some geotypical textures, right? I've very quickly created this representation of downtown San Francisco. It also has some built-in analytic capabilities. So this is Colgate Tower, and what we want to do is understand how developments might impact the visibility of Colgate Tower from the downtown area across the river. So CityEngine has a built-in viewshed tool. You can define a viewshed. It'll tell you what is visible and how much of what is visible, what is occluded, and what is occluding visibility. So here we can see the amount of terrain, streets, Louisville downtown, and existing buildings that are visible. If I drop in a proposed design, we can see these proposed buildings are dropping the view to the Colgate Tower from across that bridge. So I'm obstructing views to the historic clock tower if I put in this proposal. So it's not just 3D content creation, you can actually also do interactive analytics. And CityEngine really has been moving towards focusing on being this urban design tool. to support conceptual planning, master planning, and site planning, and also acting as a bridge for GIS information into VR, AR experiences, and specifically in Unreal and Unity. And it works as a, by creating existing condition, be it on your GIS data or GetMap data, writing a rule, or using one of the rules that we provide directly out of the Esri library, Esri lib, that you can download, drawing your design, applying your rules, evaluating your alternative scenarios, and then publishing or sharing for feedback, or pushing back up to ArcGIS Urban if that's your system of record. And it creates these varying styles of 3D content. So with 2019.1, we've integrated ArcGIS Urban and CityEngine together. That means you can take a plan and download a plan from ArcGIS Urban into CityEngine and use CityEngine to edit, modify it, apply its rules to it, and create representations. And then synchronize those changes back up to ArcGIS Urban and publish your more comparing visual as a scenario in a plan. You can also use CityEngine as your way of publishing projects to ArcGIS Urban. So it's a nice way to get 3D models into ArcGIS Urban until we have that project submission workflow later this year with the 2.1 release. So rather than just again talk about it, let's take a look at the integration here in action. So this is CityEngine 2019.1, right? I'm going to log in. So I'm logging into my organization where I have ArcGIS Urban. New under the networks pane, right? I can click the Urban and I can see all the Urban models that I have. So I'm going to open my Pasadena Urban model. Now I have in the navigator this Urban tab. I'm going to go in and grab that South Fair Oaks plan that we were looking at earlier in ArcGIS Urban. And what it's done is it's gone in and grabbed a little piece of terrain, a piece of imagery, and then the zones and the parcels that are in my plan, and downloaded those into ArcGIS Urban. I'm now going to go and grab the Esri rule library. In the Esri rule library now, we actually include the rule that is used in ArcGIS Urban. So I can actually use that rule and apply it to the features I downloaded from this plan. So I'll select the features, right? Go to my assign a rule, assign the rule to them, and generate. And the parcels that I've set to redevelop, right, I've regenerated there. If I want to add in context, I can search my organization or ArcGIS Online and add a service. So this is a multi-patch service of 3D buildings I've been in to add in all the context. I'm going to drop a rule on that to turn those into models. And very quickly you can see I've created this 3D scene from ArcGIS Urban based on the same rules with the same results that I had in ArcGIS Urban. And then I can go into my inspector and start making changes and modifications to those buildings. Right here in CityEngine. So, however, I could also, instead of using the Urban rule, use all the other rules I have available in CityEngine. So let's say I wanted to do something more custom. So I'm going to use the editing tools in CityEngine, which have advanced significantly, and I'm going to split this parcel into a specific building form, cut pieces out of it, make some edits, and then I'm going to use a more complex rule that actually has architectural detail to create an architecturally detailed building on that same location. So rather than do that for all these buildings, I'm going to import from a project I did previously on adding the detailed buildings in these redevelopment areas for Pasadena. And in this case, I actually even drew in and added in some streets and some streetscapes. So it takes a sec to generate here, but now you can see I've created a much more compelling and complete 3D model of what the future could look like. And then I can share that, right? So I select all of these, and I can publish these selected models back to a scene, so I could push them up as a scenario in a project in ArcGIS Urban, and then flip back to my city of Pasadena, and I'll look at that specific project, turn it on, right, and see those more detailed 3D buildings draw now on the web, where I can share them with the public. Maybe I want to share them out to Unreal, right? And in Unreal, make a much higher end visualization. So I select all these and export them out to the Unreal viewer, and in the Unreal viewer, I can add a significantly higher level of detail. So this is the same South Fair Oaks area, same walking paths and bike lanes, but now rendered using Unreal Engine and the export to the Datasmith directly from CityEngine. So just to be clear, that's an urban plan, an urban scenario imported into CityEngine, CityEngine rules applied, exported to Unreal, rendered with atmospheric effects and lighting to create compelling architectural visualization. But maybe that's not enough. Maybe what I want to do is I actually want to submerge people in it, and we've been working with the city on giving them access to some of our VR technology, both the lightweight mobile VR in the form of ArcGIS 360 VR, which they're going to be using to do an exploration with the public to get feedback. And then, of course, if you want to go deeper, we have the CityEngine VR template, which runs in Unreal and works with HTC Vive, and allows you to get this totally immersive experience, which is actually also multi-user. So you can create really compelling experiences. You can use our template as a foundation, but as you can see, you can make just stunning visuals with really, really gorgeous effects that are totally immersive. Okay, what else is new in CityEngine? So one thing I wanted to call out that just was released a couple weeks ago, and this is the PyPRT, Python bindings for the procedural runtime. And I'm going to jump here over to the web and show them to you. So we just released the blog. If you search for generating 3D content in Python, PyPRT, a new Python library, you'll see this blog post from Cami on this new procedural runtime. So this allows you to actually call the procedural runtime, the procedural runtime SDK using Python with an RPK to do generation just from Python. And you can write it, for instance, in a Jupyter notebook and call it generate model and create a collection of 3D models as 3D geometries based on those initial shapes. So this is available here if you go to Esri github.io PyPRT, right? This is the landing page for the new PyPRT. You can get instructions on installing. There's a series of examples and a series of documentation, so you can get started on using the procedural capabilities from CityEngine in PRT in a headless fashion. So with that, I'm going to thank you for attending, and since we are not in person, if you have any questions, feel free to drop me an email, and I will do my best to answer them for you or direct you to the person who can answer them. And thank you for attending. I appreciate your time, and have a good day.